There's hydrogen and helium, then lithium, beryllium. Boron, carbon everywhere, nitrogen all through the air. With oxygen so you can breathe, and fluorine for your pretty teeth. Neon to light up the signs, sodium for salty times.
Magnesium,
Aluminium, silicon,
phosphorus.
then
What color LED is this anyway?
I believe this is red.
Do you need more bigger LEDs?
This is 1.7.
That's good. Yeah, we don't need any more than 1.7.
But I mean, do you want to try out some different colored
Yeah,
LEDs?
sure. Yeah, do you
I've got
have?
a whole bunch.
Yeah.
Oh, that's cool.
sulfur, chlorine, and argon,
Potassium,
and calcium so you'll grow strong.
scandium,
Titanium, vanadium, and chromium.
It'd be like a challenge, so you could see if.
Oh
I mean,
wow,
why do you
those
want
are massive.
Don't you want to make it like inquiry based? They could see which ones
That's right,
they.
absolutely.
I mean, I'm just suggesting
Absolutely.
rather than telling them
Definitely.
the answer.
Absolutely.
And I was thinking about your question. So I don't see why this couldn't be used because you're using the lens. So it would be interesting to think about how does this model, the typical setup that's used in schools. So this is where it's sort of sustainable, right? How is this different or better from the typical setup that's used in schools to get these cells to work? So, I mean, typically the salt bridge is sodium chloride, right? So
That's right, yeah.
maybe, and which is not terribly expensive, but maybe thinking about the fact that these nails are just found lying around, a few pennies from some, I mean, you could sort of, and
What is the copper? Yeah.
these pennies work, do you need to have I've got thermochromic fingerprint, we're picking up by the time.
Professor,
Do
we
these-
also use copper. Both we're gonna use.
Oh, okay. So copper is a bit of a problem because it's a sort of a, almost the equivalent of a heavy metal, and when if it breaks down anywhere, it forms, the ions, like copper ions aren't so good. But I mean, if it's being used here, using fountain, does it matter if it's a 1982
Yep.
penny, or so you have to?
They should be pre-82.
So they're mainly made out of copper.
Yeah.
I don't think that one's going to work.
Yeah. Well,
One leg is
I
missing.
think it's got an
That's a
issue.
disabled one.
Okay.
But,
We shouldn't discriminate.
No, I mean,
but you might want to try. I don't know what the resistance is.
this is a big head LED.
Yeah, right.
But you could try them out and just see.
This look like lemon.
I think the orange ones might be a bit high. I'm not sure.
Okay.
Actually.
We'll try everything.
Okay. So does that sound good? I think
Yeah,
that sounds
thank
good.
you, thank you.
Oh, it's very exciting.
Why we have lemons here for?
So we've got lemons so that we can light this LED, this little light bulb.
So why not tomatoes, potatoes, something else? Why lemons?
Because lemons are acidic. So lemons have the ability to move their proton ions, so their hydrogen ions, and protons
Okay.
across them and create a
She's gone
potential
back to
difference.
Sweden last night. Oh, no,
And we can do that.
bloody
We can create this potential difference using nails and pennies or copper
No,
wire,
she's from
either.
a little-
So what is this?
So she's a botanist.
Why we have this for?
And
Well,
she's
because we've
from
got to
a
create a
little
circuit,
university.
right?
Okay, and what do you call this?
Yeah,
These are
something-
wires
that's what it
with
sounds
alligator
like to
clips
me.
on the end.
Which
so that
is
we can
about
help ourselves create a
100
circuit.
miles north
Okay, so we have alligator clips, we have lemons,
She's working
we have
at
copper
the
wire, we
San
have
Diego
pennies,
study,
we
which
have
is in
nails,
summer. She
and
has
we have
A light bulb.
what do you call this?
Or
An
something
LED, a light emitting
to
diode.
work
okay.
on.
Or simple language, light bulb.
So why it
she's
has two
trying to
legs?
get
Two legs, because one is the cathode and one is the anode. So the
to
cathode
think about
is your positive side and the anode is the negative side, so you
to
can
sort of
connect each side to your
conceptualize
circuit.
their thinking about
So what do you think is the first step, Barry?
So I think the first step is like, making an insertion here and like, inserting the nail
Okay, so let's try
on
that.
one side. So I'll put the
Well, as
nail
we
on the
know,
one
I
side.
told her about the stuff I'd done on sex
Alright, so, and making
that
an
was
insertion like this, right?
Mm-hmm.
an inaccurate
Just
presentation.
want to make sure I don't cut my hand. And then what are you going to do with that insertion?
What do you think?
And
best
you might
best
have
method
presented
here.
that.
The
But so she's trying to get them
this
to
penny will go inside?
Yeah, we can put a penny inside, right?
Okay.
You know, because we talked about how even in
And
high
so
school,
what
she
you
was
have
talking
here
about different
is a simple
forms.
battery.
I see that.
Right, this
Epigenesis
is
sort of presented
probably a little bit under a half of a volt
a
of
very
potential difference. We have hydrogen ions that are just naturally
directional
exist in
way.
this
You know what I
lemon,
mean? Like
come over and are now sitting on this penny, making it positively charged.
Okay.
And the zinc on this nail is going under an oxidation
Well, I
reaction.
think it's also
So that
you know, I was
zinc ions,
reminded
positively
of
charged zinc ions, are
the
coming
way
off and
some of
sitting
our
in this lemon
presenters present
and making
their-
this
that's
negatively
right.
charged. We now have a
But
negative
also,
and a positive
there's
terminal or
there's
anode
often
in our
very
cathode.
little
Wow, that's
nuance.
excellent. Wow. I mean, you know,
This is-
even like,
you know, they
lemon,
present
simple lemon says a lot of physics and chemistry inside.
Yeah.
So you are saying that, you know, we have two terminals. One is like, you know, positive, one is negative, and that makes it a battery. Because there is a potential difference between, because this is an anode, we call it zinc. And this is penny, we call it copper.
Copper, yes.
Okay, so these two guys making a potential difference using what? Acid of the lemon as a bridge.
Yes, the acidity of the lemon, or also known as hydrogen
There was
ion.
no nuance.
Okay, so
Let's put together.
so can I light it like this? No.
I don't think that'll work.
Oh, okay.
It's like,
This is
yeah,
going
we're
to
really
need
on the
more
board.
volts,
What we're doing
right?
is
It's going to need a
right.
higher
We're
potential
on-
difference.
So when you don't measure the voltage, how much voltage one battery can produce, and then that
It's
many
just saying,
lemons you can use.
genetics is always
do that.
presented that
Okay.
way, and then 10
So,
or 5
Wanna
years
help?
later, or 2 years
sure.
later,
How do
they
we
have
get
to.
this?
What is
they have to
this?
revise
so this is a multimeter.
rather than
Okay.
So you
saying-
can just put this
rather than
probe
having a more
onto
nuanced presentation.
these
This
items.
is-
How do we know which one is positive and which one is negative?
The red is positive.
Okay,
and
we
the black
have
is
presenters who
negative.
do that, but I just I
Put
was
them on, and we
reminded
can
that
see
straight away. I thought,
that we've got
the way we
about
did that
I
presentation.
would like to see him
5,
especially
6
because he's
volts.
so bright.
That's amazing.
Yeah, right?
0.5.
About half a
A
volt.
little bit more
About
than-
half a volt. So how
Why is
much
passion
voltage we have to
so,
generate to light a LED?
about
This is broken LED.
But we've got more LEDs.
We've got more LED, and I have more over there. Let me bin them.
Right,
and so now, why are we sure now?
right,
There
exactly.
you go, David. Catch it.
That's her point. You know, genetics is always presented as though this is the right. Now we've got it right,
Alright.
rather than.
We've got
well,
another LED. So let's see
you know,
how
we
many.
may-
Let's put
and I think
together
that's
some
what she
lemon
said, you know,
That's-
if-
and see how many we're going to take. So let's
theory
just
approach, be more
start
nuanced
putting
about
some
what
together.
the data
So I'm gonna make it-
shows. You know, we think
okay.
it's right, but you know what? It's complex, and right now we think we have a good explanation, but it may not be the only explanation. You know, because you were talking about, you know, historically how we thought DNA was, and she said,
Let's
you know,
put together
protein
5 of
production
these.
is not
5 of this,
presented
okay. That's
as
gonna be
though
more.
it's unidirectional,
That's gonna be more than
you know,
enough to
and,
light a LED, right?
I hope so.
Going to school at Columbia, graduate school.
By the way, I forgot to roll the lemons. I think rolling the lemons will.
It does, right?
Okay.
I dislike
can
this
squeeze them
professor
or
more.
roll them.
And he was a young guy.
And that
and
breaks
very
down some of
nice
the cell
guy.
walls.
He's just
So that's
nasty.
what we call that human error.
So we can do that now,
Oh,
right?
we can do it now.
I'm glad I
It just
forgot
breaks
his
down
name.
some of
I
the
wouldn't want to.
cell membranes and allows for
So
the
I
hydrogen
remember
ions to flow and
not
allows for
fully
the
understanding
oxidation reaction of the
And I
zinc
asked him.
to happen as well.
So that
We just
the
move the nails and the pins side to side there.
so that the electrolyte can push the electron in the zinc, send it to the copper, right?
Yeah, exactly. Alright, so let's see how we would do this. So now we're going to want to connect.
Why they can touch each other, zinc and copper?
No, we can never have them touch each other.
Why not?
Otherwise, it's bad.
Why not?
If they touch each other, we're going to short out our reaction, and there won't be any potential
Can
drop.
very well explain things
Okay.
that.
Because currently what we have is that we have our lemon, which is separating the charges, and it's not letting the positive and the negative come together. Because if they touch, the lemon can't do anything. The lemon is powerless to stop them.
Okay.
Okay.
So I got that part. Now I have something called suction, right?
Yeah.
So that's what you're gonna be doing now.
So how do you think we're going to connect these? We have these clips. We can hook onto things. You know, I can grab this.
Uh-huh.
The multimeter with it, or I can grab an LED with it. But how do you think I'm going to use this to make a circuit?
I think this is like this is like anode, right?
This is our cathode, right?
This is cathode, right?
This is cathode.
So cathode goes to anode, right?
Penny to nail instead of penny to penny.
For potential difference.
To create a potential difference. Okay. So let's connect all of ours.
Okay.
Like that, right?
Yeah.
So penny to nail.
Medal, not a Nobel Prize, but like another big important medal that's offered by the Swedish Academy this year. And I said, Richard Valentine, sorry. And I said...
And then one last one right here.
One last one is for... Okay, so now we can measure the voltage to see how much voltage, how many lemons we are using.
Okay. So do you want to take our...
Final voltage?
Yeah.
Okay, let's see the final voltage.
I really like his little book.
Oh, it's overloaded on the 2-volt scale.
Wow,
so
this
we've got
is 2.7
7 volts.
volt. Wow, that's lots of voltage.
Yeah, let's see if that is enough.
Can we predict that is enough voltage to light 1.7 LED bulb? Can we predict that?
Yeah, I think so.
Okay.
But let's see if we can light one of these bigger ones first, right?
Why not?
So we're going to attach this big side, our cathode, the long one to our penny, which is also our cathode.
You're right.
And then we want to attach the anode, which is our nail, to the anode of this LED.
Okay.
And we've got a little light.
Really? Yeah, I see the light.
It's a purple light right here.
I see that.
That's
an NYU color.
That's an NYU color. So we've got a pretty little purple light.
Yeah, that's
right
amazing,
here.
Yeah.
It's really faint and very difficult to see. But let's see what happens when we put in
this one, 1.7
yeah,
one.
a 1.7 volt LED.
Alright, so this is a brand new
LED.
Brand new LED.
Again, let's attach our cathode, which is our penny, to the long side.
The long leg.
And then let's attach our anode to the short leg, which is our nail to the...
Is it lighting up? You should light.
It is lit. It is definitely red.
Why is not brightening up?
It is light.
It is bright.
Or it's lit up, so you can see
it's
the
lit
red.
up. It's lit up, but
it's just not very bright.
Yeah, I expected it to be bright because this is only 1.7 voltage LED, but we generated 2.7
volts. Oh, there you can see it from the top.
Yeah, I see.
So you can see it from the top. Maybe we'll bring this in closer.
If somehow I can turn this light off, then, but which is not possible.
Yes, it's a little bit difficult to see.
A little bit difficult to see,
but it is very lit up from the top. It is very, very red.
I got sick of counting different colors.
Now
there's hydrogen and helium, then lithium, beryllium, boron.
No. This one gonna go here. Put it here. So LED bulb. So it has two layers, right? One is long, one is short, right? The long one is cathode. Okay. The short one is anode. So this one is cathode. Okay. So take the cathode, put the cathode on the long So where is the anode? Anode is yeah, it is. It is like, yeah. So let me forward. Do you see that? Yeah, I see. Huh?
There's hydrogen and helium, then lithium, beryllium, boron.
You're gonna use the lemon to make wet cell. Tonight you're gonna learn the difference between dry and wet cell when you do homework. This is dry cell, this is wet cell, but both direct current, both are DC current. You're gonna make this is current right now, but what you're gonna do? You're gonna take a lemon. You're gonna take 6 people in this table, so you're gonna take 6 lemons. and you're going to create two terminals. Guys, that's how, guys, if you don't pay attention, you're not going to be able to make batteries. So if you make, we've been talking about making terminals. So you're going to make two terminals. How many terminals? Two. This is negative, this is zinc, this is negative, this is copper, this is positive. Instead of penny, you can use copper wire. The copper wire gives you advantage because it holds more radius, so it gives you more voltage. So penny or copper wire is up to you. So, but this is how many? Now this is battery wire. It has two voltages. One is negative, one is positive. Okay. Now you're gonna make 6 battery. This is one battery. You're gonna make 6 batteries together. You connected it by alligator wire. You connected it by alligator wire, and you make a series, not parallel series, because only one light. You're gonna make a series, and then you're gonna connect it with LED bulb. LED bulb is 1.5 voltage only. So all you need to do produce 1.5 voltage. Now, while you're making the battery, I want you to do this. You're going to collect data on page 20. You're going to read page 21, and you're going to complete worksheet page 22, 23. And that's what you're responsible for. So now collect the materials from the back of the table, and good luck.
There's hydrogen and helium, then lithium, beryllium, boron, carbon everywhere, nitrogen all through the air with oxygen so you can breathe, and fluorine for your pretty teeth, neon to light up the sign, sodium for salty times,
Magnesium,
aluminium, silicon,
phosphorus,
then sulfur, chlorine, and argon,
potassium.